It's my pleasure now to introduce Bhavani. Bhavani is an independent software consultant building Python-based back-end DevOps and data systems. She also teaches Python via online month-long boot camps. She's an open source enthusiast and has contributed to Pandas and Apache Airflow. Please put your hands together for Bhavani.
Thank you. Thanks for such a nice introduction. First of all, hello, everyone. Hello, everyone. OK, nice. Good. Now you're all awake. I know we're hungry, but just to put things into perspective, I'm Bhavani Ravi. I've been fallen in love with Python 7 years back, and it's still going on. I'm an independent software consultant. I get thrown into technical problems, and I rise up from there. That's what I do for a living. And today, we are here to build our own unit testing library. And when I put out this talk and told my friends that the talk was accepted, the very first question was, why? Why even your own testing library? And I don't have a perfect answer for that. I have an answer for that. One is, it's fun. Remember when you all first started programming? Remember that moment when you've fallen in love with that first program that you wrote? It gave you that spark and kept you hooked all along. Mine was printing the first 10 numbers, and I changed the program to 10,000 and then to 1,00,000 until the system crashed. But there came a point where programs like that got really boring, and now I can do these for fun, and I hope you can too. And there's this Richard Feynman's quote, what you don't create, you don't understand, and I pretty much love this quote. And as a result of that, I created own Flask, my own version of Flask application, and that was almost a year back. It's been too long since I've had fun, so now I'm after Pytest. The only problem was I've been using Pytest pretty much extensively the last 8 months, and the 100% test coverage from the previous talk, all of that was so relatable. And I love all of these features that Pytest provides. The test runner, parameterized test cases, expected exceptions, fixtures, mocking, you name them, I use them. And show of hands, how many of you have used Pytest? OK, everybody, almost everybody. If you have not used it, your logic will look something like this, and your associated test case, which starts with test underscore, followed by you call your logic and test whether that the logic behaves the exact same way. And that's a very simple test case. This is your parameterized test case, where you pass a bunch of data and hope that all the data that you're passing behaves the same way as well. And you can also expect your functionality to raise a particular exception, and Pytest will capture that. So I thought, OK, let's start building it. And the first place to start is reverse engineer it. And I went and looked into Pytest source code. And this was the reaction. Well, it has about 130K lines of code. The earliest commit was on 2007, and so far there are 5,000 PRs being merged for the project, which is a lot more than Flask. Flask was rather simple. What I'm trying to say with all this is, it's hard to reverse engineer it. The next option was ChatGPT or GitHub Copilot, because we are all relying on that so much. But things like this, LLMs only work if there are previous examples available. Unfortunately, even if you Google right now, there are not a lot of examples on how do you build a testing library from scratch. So again, thrown out of all the options here. So building my own testing library, reflecting whatever Pytest provides as an interface, I'm going to have all these features. And let's see how that goes. First, starting with the test runner, I'm going to be live coding this. And if I make any mistakes, please be kind to me. And the test runner, this is all our version. This is not Pytest version. So it has an interface that looks like this. You do Pytest, followed by the directory that you want to test. And if we think about it, how would you write a test runner? First problem is finding out all the test functions that are there in all the test files under that particular directory. And then you have to run them, maintain a streak of success and failure, and if there is an error, you have to report them. Can we live code it? OK. I did say we're going to do things from scratch, but I kind of lied. So we're going to start with this. So here's my test function. OK. Here's my own test module, which is where we're going to fill out things. The test runner is the only thing that's going to run. Everything else is an exception, parameterized, fixture, which we will come back and fill in later. Here is my test runner, and some of the complexities I have hidden away using certain functions. So I have got all the test files. I've got all the test objects here. And the only thing that we have to do right now is run the test cases. So what do we mean when we run the test case? We have a test file with a bunch of functions. We have loaded all that function into our module. Now we have the test function name and the test function object. And running them would actually mean calling that test function object. And if I run this, so I'm going to use the own Pytest module and pass all the test cases. All this functionality of reading the directory, reading all the functions has been already written. So if I run this, it says success, no errors has been found. Whether it's really working or not, I might not know. So what I'm going to do is, in my case, I'm going to make it 10 and see what happens. OK. There we have it, our first assertion error. So it's not just a matter of calling the function to run the test case. You have to also maintain a streak of all your errors. So let's wrap this in a very nice try and except. All right, so we are going to wrap it in a nice except, and there we go. So we're going to keep a track of our exception. And under here, if there are any errors, we have to print them. So let's print it for, wow, live coding is hard. So here we go. Yeah, I'm kind of cheating right here, but it's OK. So we are capturing all the errors. We are getting a trace back, and we're printing them. So OK. We have something running here, and then there is an error under test add. This is a traceback and where the assertion error is happening. Let's also give some more meaningful things so that we know something is running. Running test case, test function name. All right. So we know that it's running certain test cases. There are certain errors. Let's revert this back. That's our test runner. So now we have a test runner which takes all the text objects, runs them, marks them success, marks them an error. We're good to go. The next thing is the easiest one of all, accepted exceptions. So looking at this pytest.races, we are going to implement the races. What can you make out of it? The interface. Races is a context manager. And context managers, if you have seen it, it comes with an entry and an exit block. It is initialized with an exception type that you're expecting. And when exiting the block, you have to ensure that the particular exception that you have mentioned should be raised. And if not, we are going to raise an assertion error. And oops, not there yet. OK. So let's go to our pytest.races. Own pytest.races. And this is my template block. So right now, to test this particular aspect of it, I have a very nicely written test case right here. So this is going to raise type error if I'm passing anything that's not a integer to my add, subtract, multiple, divide. So let's run this. Now it raises a type error. And it's not being captured, it's not being handled, because we haven't implemented this races yet. If we have perfectly implemented it, then it would just pass through and mark everything as success, because the function is working as expected. So at enter, we don't have to do anything. At exit, we have to check if the exception type is none or not. If it's none, no exception has been raised. So that is there. And if the exception type is not there, then we are raising an assertion error. Both the cases, assertion error, different logic. But how is GitHub Copilot doing all that? Because I have practiced this almost 100 times so far. So assertion error raised when the exception type is none or if it's not matched. So now let's run this. OK, that's weird. Since we have already handled the exception, we also have to mark it as true, that you don't have to do anything, just everything is nice and good. So now it has ran the test cases. It has also ran the test races, and things are fine and well. But is it really working well? So instead of this zero division error, I'm going to mark it as type error as well. Now our function should fail because it's expecting something and resulting in something. There we go. We have an assertion error. Yes, raised. A type error has been raised instead of a zero division error. So yeah, kind of works there. Let's revert this back. And life is all good, nice, and successful again. Good. The next thing is parameterized test case. Again, this might look very difficult, but it's also very simple. You know the drill. Looking at pytest.mark.parameterize, what can you make out of it? What Python construct it is? A decorator. And if you look at it, it's not just a normal decorator, it's a decorator with arguments. Oh, scary. When it's so first, you're registering the parameters. The second, you're registering the function. And then you're going to return a wrapper. All of that has to happen. And once you have the function, when the function is being called, you have to run it n times so that all your subtests also runs. And log the results. Even if there is failure in either one of them, you have to ensure that that is captured. And finally, you will get there. So pytest.parameterize, here is my template. Of course, GitHub Copilot is going to fill it. The keys are, first the test case, the own test.parameterize, looks something like this. Here I've used Python's eval, don't ever use it in production, yada, yada. And yeah, so to the parameterize, I'm passing like 3-4 arguments for me to test it. And your keys are going to be this, your values are going to be this. First, when registering the arguments, I have to put it in a nice format so that I can just pass it as argument. So let's make a test args list. And here we are going to, different than the previous one, but sure. Next, what we're going to do is we are going to, when the function is being called, when your test case is being called, you're creating subtests. So let's create I, test arg in enumerate of test arguments. Then we'll print that we are running the subtests. And also call the particular function with the test argument. So previously, when we were calling the test function, it was just calling that one particular test object. Right now, what we are calling is the wrapped decorator. So inside the wrapped decorator, instead of directly calling the function, we are calling the function n number of times based on the parameters that is getting registered. So let's run this. Yeah. So you have running subtest 0, 1, 2, depending on the parameters. If I go and add more, it's going to add more. If I change something here, that also gets handled because we have taken care of assertion errors globally. You don't have to do anything particularly inside the parameterization. So that is also good. OK, bad with math. Great. All good. Now, we have a decorator that takes arguments and a function looped over it, all good to go. The last, but the scary part, is fixtures. This is a scary thing for me, very easy to use, very nice feature of Pytest, but this one sucked my brain out because I have to implement it all by myself. And fixtures are great because you can do a ton of things from there. You can define a whole large data set and have it available, and multiple tests can use it, or you can do your setup and tear down, and Pytest comes with enormous amount of features. There's auto-use, scoping, you can put it in your conf test, and the variety, no wonder they have 130K lines, right? They want to make your life easier. So it's a decorator again, and you can register a function as a fixture, and when you are running the test case, you have to ensure that you are passing the argument, which is a fixture, which in turn is a function, which is decorated. Weird. Yeah, that's how I felt too. Handling test argument, that is a fixture. And then you have fixtures that are just data fixtures, which is going to return dictionary or a list or a tuple, or you have yielding fixtures, which is going to yield and then do something later. So all of these things are going on. Let's try to implement this. So here is our beautiful fixture, and that's it. That's all you have to do for fixtures, because you register a function as a fixture, and your job is done. But a lot of things that you have to do is in your test runner. You have to ensure that you are passing the arguments. So far, when we are calling the test function, we are not passing any arguments. So first thing that we have to do is to find out what arguments, like parameters, are there in your test function. So this particular construct, code/covariable names, will give you all the arguments of a particular function. And for args in test args, we have to see whether that particular fixture is in a fixture mapping. But we haven't defined our fixture mapping yet. So let's go to that. Here I have some logic to get all the test functions. This does nothing but get all the members of the module, finds out all the functions that starts with test underscore. This time, we are also going to check if members of one, which is the object, dot name is a fixture wrapper, because we have wrapped it in a fixture, then we are going to store it in the fixture wrapper, fixture mapping. So great. So it's in the fixture mapping, then you call it, that is your test argument. Let's also create a list. Of course, this code is never going to be used or be in production, so all the solid Yagni principles doesn't apply here. List. All right, we are not going to use it. Okay. Test args dot append. We are going to call the fixture and get the result, put it in a test arg list, and gonna pass it to test arg list. Now, when I run this, it's gonna pass. Let's uncomment these test cases. Here I have a fixture that is getting registered, and we have a test con, which is going to execute a particular connection, which is also going to raise an operational error, because I don't even have the database. It's raising an assertion error, which is weird, because it's expecting an operational error, but it's actually getting an attribute error. What do you think is happening here? Weird errors like that has popped up, and the problem is because of what's happening in confixture. If we go here and print out what is actually getting passed when we are running the test case, is you can see that it's a generator. This is where I said it's an yielding function, not a direct data fixture. So we have to do something even more crazy. Again, back to our test runner. Here we have an argument, which is the fixture. We know that. Great. Now we have to get let's get the fixture object. And we have to check if the fixture object has the next argument in it, so that we know it's a yielding it's a generator. If it's a generator, we're going to call it and then store that value. Else, we're going to call the object directly. So that's the logic. There are two types of fixtures. One is an yielding fixture, which is a generator. The other one is a direct fixture object which just passes the data, and we have handled both the cases. Now let's run this. Oh, still an assertion error. This has also happened quite a bit of time, and still it's still a generator object. Now I'm confused. Any help? I didn't call it, yes, great. Oh, I didn't call this. Yep. It's a fixture object. We're calling it, and then, okay, this is why I was scared of doing this, but okay, I'm going to add more print statements, very classic programmer move. Fixture object, what is coming here? It's a wrapper. Right. Okay, I'm going to pull out another classic programmer move, is have your backup code, go through that, see what it does, and just go with it. So here is my perfectly running fixture stuff. I'm going to copy paste that. All right, so yeah, we have the fixture value here. We are going to call return on it, or we are going to directly call next on it, or just going to directly append it. Oh, yes. So that's there. Perfectly out of sync. OK, much better. Yeah. Still a lot of things, test args to pass. All right. Whew. Thank you. So yes, there is our fixture, which is a yielding fixture. Next, we call next on it. If not, if it's a data fixture, that will also work. So after so thank you for that. I forgot to put the thumbs up over here. So if you want to go through the same thing, you can go to my GitHub repository and try it out on your own. There is a blog post associated with it, which needs an update, since a lot have changed in the last 3 months. And what can you do to have fun is you can try implementing mocks on top of this, or try testing this testing library, or testing your own testing library, or build your own X and have fun as a part of it. Yeah. Most importantly, don't forget the first program that you ever wrote, which was very fun and kept you hooked so far. And if you want to check out my other works here, if you want to talk about Python, DevOps, data ops, I'm here. Thank you.
We have some time for questions. We're all so hungry. Oh, just up there.
So I have a question regarding once you have the test completed, usually you end in a big trouble analyzing the test, because usually you just need to look at the assert statements. But when things grow a bunch of tests, you have hundreds of tests, and analyzing that is quite difficult. So did you have any strategy once you have everything completed? Just, for example, instead of doing the assert, raising specific assertions or custom exceptions? Do you have something in mind?
I don't quite capture that question, exactly what you're...
When you once the test is completed, and the analysis of the test is a bit difficult. So do you have any strategy for that?
All right, so assertions, I don't know whether this is what you're asking, but if you do it with Pytest, this is a Pytest version of test case that's here. Yes. So when you do it with Pytest, I'm going to change things over here. Yeah, any number would work. And I'm going to run it with Pytest. I have printed it pretty badly, right, because we are building it live. But when you do it with Pytest, it's going to show you exactly where that error happens. And it also has a very nice traceback that you can print with more verbose things. So it doesn't matter at what level the error occurs, you will have a complete traceback of things. And there are options in Pytest to do that. I think this case, it's just an assertion error happening at that particular line. But if you have it in your logic, there also it works. So let's say you are expecting 5 here, but instead of add, I'm going to change this to, let's do something fun, 10 always. Then it's also going to give you that whole traceback. Yeah, so here it says, assert on the left you get 10, but on the 5, if you're making any particular logical error, that also comes as a part of the traceback.
Okay. Thank you very much.
No other questions? No? Up there.
What do you think is the most useful insight you've got about the internals of Pytest that you learned from this reimplementation? Is there some part of the internals that you wish people better understood?
Oops. I'm going to go back to the slide where I was pretty overwhelmed, scared. It was very hard to even just look at it or understand it because it has built for so many different use cases. Even something as simple as fixture, it behaves completely differently to what I have built. So I have stopped drawing inspiration from Pytest way early in the process and just built my own version. So that's.
Thank you for your talk. Could you talk us through the entry point of your code, how it iterates over the test files, finds the test classes, finds the test methods, and then works out what to run?
Sure. So it's pretty simple, but sure. All right. That's my test runner, and it gets test files and then a bunch of test functions. So test files is nothing but reading the directory. If the directory does not have tests in it, you skip the directory. And if it does have in it, get all the files that starts with tests and ends with py, and then return them. So that's all the test files inside any particular directory. Of course, I've done it for only one level. And for the test function, I'm importing the whole module, like the whole file, and going through its members, using whether it's a function. And if the function starts with test underscore, that is a test function, and I'm passing them back. Does that help?
Thank you.
Okay, thank you. Thanks, Bhavani, for such an engaging talk. As a token of our appreciation.
Thank you.
Thank you.
Thank you so much. One small thing, very thank you to PyCon AU. They have sponsored me to come all the way from India to present this talk here. Thank you so much from the bottom of my heart.